So when we're solving quadratics, there's something called the discriminant. The discriminant doesn't actually solve anything for you. The discriminant is actually built into the quadratic formula, which is what the next video will be. But this video talks about the discriminant, and the discriminant serves a purpose. It's not just random. It does have a purpose. The discriminant tells you how many solutions you'll find. So we talked a little bit in the last video about solutions and how you could have one real solution, two real solutions, or two non-real solutions. And that's what the discriminant tells you. It tells you before you even get started, how many solutions are you going to have? So we have one real solution. We have two real solutions. And we have two non-real solutions. And non-real solutions are for those quadratics that don't actually touch the x-axis. So the discriminant has a formula, which is really nice because in formulas you just identify what numbers need to replace the letters and you plug them in. And the discriminant formula is b squared minus 4ac. So let's work a couple of examples and see what I'm talking about when I say the discriminant tells you how many solutions you're going to get. So if my function, if my quadratic is x squared plus 4x plus 1 and it equals 0, first off I got to make sure it equals 0. Make sure you equal 0. And then we're going to identify the A, the B, and the C. And then we're going to plug those in, and we're going to use our calculator. I want you to use your calculator, and I want you to use a lot of parentheses. So we're going to plug in, and we're going to solve in our calculator. So our A is 1, our B is 4, and our C is 1. So we're going to take that formula, b squared minus 4ac, and we're going to put some parentheses everywhere, and we're going to plug numbers in. So b is 4, so we're going to take that b out and replace it with a 4. A is 1, we're going to take that out and replace it with a 1. Same thing for c. So b squared minus 4ac for this equation, for this quadratic, becomes 4 minus 4 times 1 times 1. And I want you to put this in your calculator because, yes, I know you know the order of operations, but people tend to know the order of operations and then still do their own order of operations in their head. So we're going to type it in to our calculator exactly like we see it on the paper with all those parentheses. And we're going to just hit enter and let the calculator tell us that, oh, I forgot to square something. I got to square that b. So let's do that again. We're going to do parentheses 4 squared minus 4 times 1 times 1. Don't forget to square it. That'll really destroy all of your work. So when we plug it in correctly, we find that the answer is 12. So here's how we determine if we have one real solution, two real solutions, or two non-real solutions. 12 is greater than 0. We've got a positive number here. I like to look at it and go, oh, that's positive. Well, if you have a positive answer, then you get two real solutions. So if you were to go on and go, okay, well, I'm going to go ahead and solve this and figure out what the solutions are, you would get two real solutions. So what you can do with the discriminant is you can determine if it's worth your time to go on and solve the problem. Am I going to get two real solutions? Am I going to find where this graph crosses the x-axis? Am I going to get one real solution? If I get one real solution, what does that solution mean when I solve and look for that where I cross the x-axis? Or if I know that my graph doesn't intersect the x-axis anywhere and the x-axis is tied to certain information, if you're looking at it as a real world problem, the x-axis might be tied to dollars earned, it might be tied to lost sales, all sorts of different things. It can be tied to time, most often is where you'll see it. If you're going to get non-real numbers, then you know that your graph never touches the x-axis and you're not going to be able to get any useful data from that that quadratic. Let's do another one. So 2x squared minus 6x plus 15. We identify our a, our b, and our c. So we have 2, -6, and 15. Then we take our function, or we take our discriminant, sorry, don't even know what I'm talking about anymore. Take our discriminant and we plug things in. So let's take all those letters out and put parentheses in. Remember to square it. And we're going to replace the b with a -6, the a with a 2, and the c with a 15. And then we're going to plug all of that into our calculator. And we're going to plug all of those parentheses into our calculator because it's really important that we get parentheses around these negative numbers when we plug them in. So we get -84. When you get a negative number, so you get a number that's less than 0, not equal to, just less than 0. You get a big old negative number. That tells you that there are two non-real solutions. Now, for just pure math's sake, we'll go through and we'll solve and figure out what those two non-real solutions are. But in a real-world application, you may not need those. If you don't have a real solution, you may not need to go any further. But knowing that you're looking for two non-real solutions also helps you be a little more prepared for what your answers are going to look like and not be completely baffled when you start getting I's and numbers that you're like, these are imaginary numbers, these are complex numbers. You're expecting it. It's just kind of a heads up, hey, this is going to be a little odd. And then our third example, x squared plus 6x plus 9 equals 0. That up there should have equaled 0 too. Our a is 1, our b is 6, and our c is 9. So we take our b squared minus 4ac, take our letters out, replace them with some parentheses, and then replace the b with a 6, the a with a 1, and the c with a 9. Pull out our handy dandy calculator. And we get that it equals 0. Well, if you equal 0, 0 equals 0, you're going to get one real solution. And that's handy to know because then when you get to the end and you're like, I only have one number. Was I supposed to only have one number? What if I'm supposed to have two? If you've done the discriminant, then you know, hey, I was only supposed to have one real number. I'm good. That was the number that I was looking for. So the discriminant is just a way of kind of looking into the future of where your problem is going to go.